And the next, we're honored to invite Mr. Rick O'Connor, the President and CEO of Open Hardware Group. Hi, Rick, can you hear me?
Yes, I can hear you fine. Can you hear me?
Yeah, very clearly, and we can see your face clearly. Thank you.
All right, I'll share my screen and we'll get started. Thank you very much for inviting me to give a talk today. This talk that I'm going to give is, I hope you can see my first slide. This talk I'm giving today is an excerpt from a keynote presentation that I gave at the RISC-V week conference in Paris earlier in May. And I reviewed 3 lessons the open hardware community has learned over the last 18 to 24 months in developing open source IP, open source hardware, and in particular, some of the legal implications and IP licensing. So I'll just jump right in. And I think I will. So I'll give a quick overview, and if you're not familiar with the Open Hardware Group, I'll give a quick overview of the ecosystem, and then I talked through 3 different lessons. I'm not going to go through all of that. Like Tim, we'll have bonus slides in the back for you to look at later. But I'm going to talk specifically about the lesson 1, the permissive use and licensing considerations for open source hardware. So the open hardware ecosystem, Open Hardware Group ecosystem, is a nonprofit community headquartered in Ottawa, Canada. That's where I am currently, as well as Brussels and Belgium through our partnerships with the Equip Foundation. And this is an ecosystem very similar to the kind of work that Tim just described, but with more of an emphasis on high volume production SoCs from major semiconductor companies today, and figuring out, and ASIC companies, and figuring out how to curate and collaborate on open source hardware design with hardware engineers and software engineers, and in particular, open source RISC-V processors. And doing so in such a way that this IP fits into the existing design flow and tools that these companies use today. So one of the contrasts compared to what Tim described is this ecosystem is focused fundamentally on the IP, the RTL, the verification of that RTL and supporting that RTL, not at all focused on developing open source EDA tools or open source PDKs. The adopters of the IP from the open hardware ecosystem, they're free to choose whatever EDA flow they want, and free to choose whatever PDKs they want to synthesize this RTL into. We have a very, very large community that has been growing rapidly. We're over 88 members and partners at the table, and here's an example of all of the different corporate members from very large systems companies and silicon companies, tools companies, software companies, and including foundries such as Global Foundries, who is a strong member. We got started working with the academic community. ETH Zurich and Luca Benini's team there was instrumental in helping us start the Open Hardware Group. So we have a rich history of academic relationships, including Rios Lab, which we're honored to have, and a very large partner ecosystem as well, with a number of very, very familiar names, as I'm sure you can see. The way that we're structured, the community is structured, is there's really 2 main working groups. The Open Hardware Board of Directors oversees a technical working group and a marketing working group. And inside the technical working group is where most of the action is. There's a cores task group that looks after all of the different processor cores and the roadmap. We have more than 11 different open source RISC-V cores under development in the Core 5 family today. We have a very, very busy and active verification task group. All of this is System Verilog UVM based work. And arguably, we think the community has produced the most comprehensive and robust verification infrastructure for RISC-V processors within our verification task group. And then software task group and hardware task group that are basically internal customers, if you will, for the cores, where we build SoCs and with Global Foundries and 22FDX, as well as FPGA emulation platforms. So overall, there are more than 20 different active projects across these task groups, from the RTL for the RISC-V cores themselves, the verification, as I mentioned, compiler work, IDE work, operating system work, FPGA work, and so on. And I also want to draw your attention to, this is an international, sorry, is there a question? Okay. This is an international ecosystem with an Asia working group and a European working group. So we'd welcome your participation in our Asia working group. It's a newly formed working group that's quite active in identifying projects of interest to the Asia Pacific region and under the umbrella of the global engineering efforts within the Open Hardware Group. So that's sort of the history or overview of the Open Hardware ecosystem. And this ecosystem became operational just about 2 years ago. So this keynote that I gave at the RISC-V week looked at 3 different lessons that we learned over the course of those 2 years. And for the next portion of the talk, I'm going to specifically focus on the IP licensing considerations that we examined and discussed at the beginning of creating the Open Hardware ecosystem and sort of where we ended up today. So we'll jump right into it. First lesson learned is clearly permissive use licensing is a must-have, and I'll explain what that means in further detail on coming slides. But fundamentally, a permissive open source licensing approach and processes behind the engineering release methodology. It's not just here's the license for my code, but how is that code going to be maintained, curated, and brought forward over time. So the processes around that as well are important to minimize overall business risk for corporate adoption, as well as the legal risks. And open source is successful when large companies have figured out how to adopt the open source IP and generate commercial benefit from it. And that's a fundamental chasm, if you will, that we as a hardware industry need to cross and actually embrace, understanding how commercial adoption of this open source IP will happen and will benefit the contributors and adopters of the IP. So the first thing to look at as part of the open source licensing in general is this is a report from the White Source Software Database. It's a fascinating report. I've got a couple of slides on it, and it takes data into consideration from the end of 2021. So it's pretty fresh data. And this database has more than 4 million open source packages in the database that cover 130 million source files and over 200 different programming languages. And what you really see here is the use of permissive licensing has continued to grow, and copyleft types of licenses. And if you're not familiar with the difference, copyleft means there's rules for you to that you must contribute back any improvements. Permissive licensing is really, the code is there. Take it, use it, modify it, improve it. Doesn't matter. You do not have to give anything back. The ethos being there that if we do a good enough job in the ecosystem, you will be able to, you will want to give back because you are realizing commercial benefit. So sorry, I just got distracted with a chat message there. The other aspect of copyleft licenses and permissive is copyleft can have implications of potential IP exposure within a company that might not be desirable. So a company might adopt some IP, make an improvement using some of their own proprietary know-how, and clearly a copyleft license that requires improvements be granted back could expose some proprietary know-how that a corporation might not want to actually have exposed. So following on from that, if you just look again at same sort of data sliced in a different way, copyleft versus permissive, you can see the continued increase of permissive licensing through the end of 2021, with Apache being the clear top license in terms of adopted permissive licensing. And one of the key differences between Apache and MIT is underlying patents that might cover the code, the IP within the license need to be included with an Apache-based license and are not included with an MIT license. So what does that mean for corporations then? So again, as I said earlier, there's really a strong requirement to understanding a path to commercial success, because the ongoing existence of open source communities and development will happen as a result of large corporations participating, giving back, and being commercially successful with that flow. And typically, these large systems and semiconductor companies have very, very, very deep patent portfolios. And naturally, they're risk averse, if you will, in terms of having these some unwanted patent exposure that might result from a copyleft GPL style license. So the ecosystem needs to be structured such that these companies can see commercial benefit and they give back as a result of that, as opposed to being forced to give back through a GPL copyleft kind of licensing terms. And Apache is very effective in terms of how it is structured. Most large systems companies, hardware companies, and semiconductor companies today are involved in some form of Apache-based software project. And that's excellent because you have a legal precedence then that those corporations are familiar with Apache, they understand it, and have already embraced it. But is Apache enough? I mean, Apache is a software license. It's written fundamentally around copyrights associated with software, because most software is copyrighted. And how does that stand up for hardware? So we believe that Apache's not enough. It's a very, very good starting point, and it can be leveraged into a license called SolderPad. So SolderPad fundamentally is an Apache license with some extensions, if you will, some add-ons. So this is a permissive open source hardware license. It's based on and extends Apache 2.0 with an SPDX license identifier, but it covers physical hardware and open source silicon and gateware within the definitions. So this is about a paragraph, half a page worth of extra definitions that modify and clarify and extend a handful of Apache definitions, so that the scope explicitly covers open source hardware. And these slides, as you can see, were provided by Andrew Katz at Moorcrofts. He's one of the world's leading open source software legal experts, open source licensing, I should say, legal experts. And while not yet approved as an OSI license, we believe that this will eventually have an OSI approval. And fundamentally, the way that SolderPad is written, it can be treated, your license can be treated as plain Apache 2.0 if that's the direction you choose to take. And the SolderPad license is governed by the FOSSI Foundation, which is a free and open source silicon foundation that's headquartered in Europe. So some of the changes that are in here deal with the way that authorship is described in Apache, as well as rights. So we extend the notion of a copyright to something broader called just fundamentally rights, that we can include other intellectual property, which applies both to hardware and physical silicon design. So rights means the copyright and similar rights, including design, and semiconductor topographies such as masks and the databases that are associated with those designs. And authorship is extended to cover authorship and design. Keep in mind that SolderPad or Apache fundamentally is a copyright-based license with an author of that copyrighted material. So the rights, copyright being extended to rights is important, and then the authorship being extended to both authorship and the design of this IP is an important consideration. And coming up to my last slide, and I'll be able to take some questions. A couple of other extended definitions within SolderPad is both source and object form. So source is extended to cover net lists, board layouts, all CAD files, all the traditional source material you'd expect to see in a hardware design. And object form is extended, again, to all applicable forms of hardware, including physical hardware, silicon, gateware, and covers the paragraph that's listed here. Everything from artwork and bit streams for FPGA, S records for some of the hardware, some of the software material, and so on. So we think the best way to secure open source hardware IP is using SolderPad. It's based on Apache, which is the most prevalent permissive-based open source license in use today. And it will continue to grow as both more open source software projects continue on. Apache is going to get stronger and stronger, and leveraging that strong base with SolderPad, I think is the right thing to do. So that's the last of my slides around lesson 1. You can learn more about the Open Hardware Group by visiting openhwgroup.org. We have a ton of different GitHub repos. Just go look for us on GitHub, and we have monthly webinars that we broadcast under Open Hardware TV if you want to go and learn more. And then, as I mentioned earlier, there's backup slides that have all the details around lesson 2 and lesson 3, around the IP quality and the roadmap and ecosystem requirements for creating successful open source hardware communities. So that's the end of my talk. Just focused on lesson 1, the licensing, and I'd be happy to take questions. Don't be shy. If you're asking questions, I can't hear you yet.
Wait. Hello, Tim. Can you hear me?
Yes.
Thanks for your sharing. My question is, what's your view on the industrial landscape of open source hardware ecosystem in the future, like 7 or 8 years? What kind of role do you expect open hardware group to play in the industry by then?
Right. So that's a pretty broad question, but so we see today there's a number of cores that this ecosystem has already fully verified. We've, if you will, frozen the RTL and ready for use in high volume production SoCs. So there's a hybrid that's starting to emerge in these SoCs where some of the IP that's being integrated into the SoC is in fact not just an open ISA, but an open source RTL and IP implementation of a processor being integrated into that SoC. So with some of the cores that are in the open hardware Core 5 roadmap, they are in production in high volume SoCs, ranging in applications from health bracelets to Wi-Fi radios and different Bluetooth and different wireless radios to embedded controllers and factory automation and so on. And we just see that increasing. As I mentioned, there's more than 11 different processor cores in the Core 5 family today under development in this ecosystem. There's an interest in some of the uncore IP that goes into an SoC. So scaling fabrics, so like network on chip fabrics to cluster, say quad or octal core configurations in a coherent cluster. Some interface IP, a chiplet activity. So we see more and more, interest in sharing some of the common elements and IP blocks that are required to build these SoCs, and the companies being willing to collaborate on that, and a hybrid of commercial IP being attached to those open source IP blocks.
In progress.
So I think you'll see more of that happening. We've like Tim said, through a pandemic, started from zero and have close to 100 different companies participating in this ecosystem now, and some of the very large hardware companies to be counted in there, and we expect that to continue.
Well, thanks.